Not sure how they're going to do
Okay, let's start. So your exam is on Friday, and today's and Friday's class I'm going to do a review. So today's class is more focused on pretty much like a lecture where I'll go over a few things I think are important and sort of give you the recipe of how to solve the problems. And then the next class on Friday we'll do it like a quiz, just like we did for the second exam. I'll have a question, you guys solve it, and then use your iClicker to log your answers. Okay, and I'll count your score for the in-class quiz. So this is your chance to get a lot of points because there'll be a bunch of questions. So no iClickers today. Okay, so your exam 3 is focused on chapters 14 and 17, which these are chapters on using F equals ma. And this is pretty much what you need to do for every problem you see in the exam, except perhaps if you see a moment of inertia problem, then you don't have to do this, right? So draw a free body diagram. You expect it to show all the external forces. Don't show a mass times acceleration. Those are not external forces. Those are inertial forces. Show a coordinate frame. How do you choose a coordinate frame? There are just three options. One is rectangular. This is x, y. Okay. If things are moving in, if the best way to represent motion is motion in x and y direction, then you go off using a rectangular. The other one is polar, which is r theta. This is kind of obvious. If you're given the position of the particle or body is a function of r theta, you'll be given an equation of the curve in terms of r theta, then go for polar. And if not, then use tangential anti coordinates. Okay, the best way to figure this out is you will be given that S, you'll see an arc length somewhere, arc length S, or other way you can distinguish anti-coordinates is you'll be given, you're told to find AT, A theta, or AT and AN, or another way to find this is you will give an equation of the curve. X squared plus y squared equals r squared is an equation of the circle. So you'll be given one of those three things. Now in some cases, like things moving in a circle, you're free to use either frame, polar or anti. So circular motion can use 2 or 3. But please try to draw free body diagram, because we award points for free body diagram. Sometimes we actually deduct points if you do not draw free body diagram, even if we have not asked you for a free body diagram. I would say just draw free body diagram. It doesn't take time and it's easy points earned. Another thing is, I've seen people draw really small free body diagrams. Okay, well, please draw big ones. One is it's easier to grade. The other thing is, if you draw very small free body diagram, it's very hard sometimes to even see where the forces are acting, which direction the forces are acting. So it's also important to lay down the forces in the right direction. If you do not lay it down in the right way, then if you draw a very small figure, you cannot see where the forces are, which direction they are. You'll probably get the rest of the question wrong. So once you do that, set up the equations of motion. Okay. When you see a problem in this particular exam, it could either be of two types. One is it could be a particle or it could be a rigid body. The way to distinguish what type of problem it is if you're given dimensions of the object, then it's probably a rigid body problem, chapter 17. If it has got no dimensions, then it's a particle problem. So for particles, you just have two equations. F equals ma. These are two equations. Let me write this way. The reason I wrote it as two equations and a vector is because depending on your coordinate frame, if it is rectangular coordinates, then this will be fx equals mass times acceleration x. Fy equals mass times acceleration y. So two equations. If it is nt coordinates, it will be fn equals mass times at and ft equals so on and so forth, right? So you'll have two equations from that. For rigid bodies, you'll have two equations from this. Again, depending on the coordinate frame, you'll set up the two equations. And the third equation is either and mg is ig alpha or if you want to use moment about another point, you need to write this equation. This is one equation. This is one equation. Now, one common mistake is people use this equation. So they write two equations here, they write a third equation, and they write a fourth equation. You cannot write two equations from this. These are not two equations. This is just one equation. If you write this twice, you'll get the same equation written in a different way. So don't say that I've got another equation by writing this equation again. So use one of the two, don't use both the equations. Okay, it's the same equation. Okay, if you want, there are, for rigid body, we have special cases. One would be curvilinear or rectangular motion, rectilinear motion. Okay, this is things are moving in straight lines or in curves, but they are not rotating. So no rotation. In this case, alpha is 0, right? And you could write either mg equals 0 or mp equals rg with respect to p times mass times ag. That is, when you have this type of motion, the first two equations are valid, F equals ma. When in addition you need a third equation, the third equation actually simplifies this. So special cases, simplification of m equation. The second case is fixed rotation about fixed axis. In this case, AG would be equal to 0. My bad, sorry. That's not true. AG will not be equal to 0. In this case, I would recommend using this equation. So let's call this A and B. So in rather I would say use A or B. Okay, you could use either of those equations, but they don't really simplify because AG is not equal to 0. However, I recommend using A. Okay, that's how we solve all the problems in the book. Okay, and the final step is if asked. Okay, so this is optional. It is kinematics. So if you are asked for velocity or position, then integrate A or alpha as needed. So let me put V omega. V is the linear velocity, omega is the angular velocity, R is the linear position, and theta is the angular position. If you ask for those, then you're going to take A or alpha, which comes from Newton's laws, and integrate it. Okay, so today's problems, I'm going to just go for this particular recipe. I'm just going to use this for every problem I do. Okay, if the supplied force F equals 150 newtons, determine the velocity of the 50 kg block when it has risen by a distance of, so delta S is 3 meters. Initial speed is 0. Okay, so before you even start this problem, you have not been given the dimensions of any pulley or any mass, which means it's a particle problem. It's chapter 13 problem. Okay, so let me start drawing with the free body diagrams. F, B, D. Okay, so if you're confused, just draw all free body diagrams you think of. Otherwise, you can actually do it judiciously. Like for example, you can figure out what force would be applied here by not actually breaking it down, but just by looking at the figure. So I'm just going to do it slowly instead of trying to do things in my head. So I'm going to draw free body diagrams for each of these pulleys. That's F. So since the string is inextensible, the force on one side should be equal to the force on the other side. That's why I drew the force in the same force on the other side. So this has to be 2F for the pulley to be in equilibrium. This force has to be F. This force on this part has to be 2F. So this force is also 2F. And since the string is inextensible, the force on the other side of this pulley has to be 2F. So this has to be 4F. And finally, the mass is subjected to the same force 4F. It's subjected to mg downwards. That's about it. Okay, so free body diagram is done. Next, we move to the equations of motion. So going back to this, a lot of things here, but we recognize it's a particle problem, and so we only have to use these two equations, F equals ma, right? Just two equations. So let's go back to the problem and see what we can do. Now we could write F equals ma in the x and y direction, but there's no real dynamics in the x direction, so we just don't write Fx equals mass times Ax. We just write Fy equals may. So for the mass, we have mg acting downwards. I'm going to assume my downwards is positive. Okay, if you think that's confusing, if you still want to stick with upwards is positive, we can do that too. Let me do it this way. If upward is positive, then 4F would be positive because it's upward, minus mg equals mass times acceleration in y. So 4 times 150 minus mass is 50, gravity is 9.81 equals 50 times AY. If you solve for AY, it will come out to be negative, right? Because 600 minus something small. So the answer is sorry, my bad. It should be positive, right? 2.19 meters per second squared. So the force is greater than mg. So the net force upwards is greater than mg. So it's going to move up. So then we are asked to find the velocity when the particle A has moved a distance of 3 meters. Okay. What we notice is that the acceleration is constant. If the acceleration is constant, you're allowed to use those formulas which we did in probably in the first chapter. V equals V0 plus AT, S equals UT plus half AT square, and there's a third one. What's that? V equals V square equals V0 square plus 2AS. Okay. So we are told to find velocity, we are given displacement. So we need to find the relation which relates velocity with displacement. Okay, out of those three equations which I just said, the one which relates velocity with displacement is the third one, which is V square is V0 square plus 2A delta S, right? So here's something to note. If I told you f was say 4t or 5t or 6t or 60t, then acceleration would be a function of time, and you shouldn't take that equation. So if f was, let's say, 150t, then you'll have something to do with time right over here. It won't be a constant, in which case you should not use this equation. This equation is only valid when acceleration a is a constant, like this. If f was a function of time, this would be a function of time. You cannot use this equation. You'd have to use first principles. You'd have to use calculus. The formula is v dv ds is equal to 2a, right? Let me put that out a little bit later. Let me finish this first. So v is unknown. Initial velocity is 0. 2.19 times 3. So velocity is 3.62 meters per second. Okay, so what if f was 150 times t? Okay, this is not this problem, but I'm just making up my own problem. What if the first was that? If the first was that, then ay would be 4 times 150 t minus 50 times 9.81, right? So you notice that acceleration is not a constant, it's a function of time. So now if you want to use this to solve for the velocity, then you'll have to use this formula. v dv ds equals ay, where ay comes from here. Well, you can't use this, my bad. You can't use that because if you put time here, then you can integrate ds. So you'll have to use either this formula. You'll have to use dv dt equals ay, and then proceed. Or if I had given you, well, actually a better way to put this question would be not to give it as a function of time, but to give it as a function of distance. If I was to set this question again, I would actually give it a function of displacement, so that you then use this formula and then proceed. Okay. If I had given it as a function of time, I would rather give you time in the problem. Find the velocity when the time is 2 seconds. In this case, I've asked you for the velocity when the displacement is 3 meters. So that's a small variation, but this thing, many people get it wrong. They start assuming this formula when the acceleration is not a constant. That's not right. Happens every single time. There will be at least 50% of the class which will do that. Okay, any questions on this? Okay, next we're going to do a rolling problem, rolling sliding problem. I think this is an important problem because if you do not see in the exam on Friday, you should definitely see in the finals. Okay, because every time I've taught this course, we've asked this question. So you can go through this. I've actually posted all these things beforehand. This is basically a summary of how to solve a rolling sliding problem. So you should go through this. And sometime back, I posted 4 questions. There are only 4 questions in the book on rolling sliding. There are probably more, but I think I just picked 4 of those questions. Try to solve all of them multiple times till you get it right, because as I said, this is a very important problem. Okay, so I'll solve a rolling sliding problem now, but this is something which I've already posted, and it will be posted when I finish my notes for today. Okay, so let's solve this problem. Very similar to the problem you did in the homework. I think is it the same problem? Was this a homework problem?
Yeah.
maybe different numbers, I don't know. I mean, it's worth solving this, I think, even if you've done this before. So I'll go through this rather quickly because you've seen this. The spool has a mass of 100 kilograms and a radius of gyration of 0.3 meters. If the coefficient of static and kinetic friction are US and UK as given, determine the angular acceleration of the spool if P is 50 newtons. So the question asks you to find alpha, or the angular acceleration of the spool. So first of all, you're given the dimensions, you're given the radius of gyration. That's a big hint that this is a rigid body problem and not a particle problem. So you'll have to use F equals ma and the moment equation. So let's draw the free body diagram. Okay, so force P as shown. Mg acts downwards. There's a normal force at A. And then there's going to be friction force which is going to oppose motion. You can draw it this way. Okay, so rigid body problem, so you're going to set F equals ma in the x and y direction, and a moment equation could be any point you like for the moment. So let's write F equals ma. Fx is mass times acceleration in the x direction. So the net force is P minus Ff equals mass times acceleration in the x direction. For the y direction, MAY, we have the net force is N upwards, so it's positive, minus mg, but that's downwards, equals mass times acceleration in the y, which is 0, so that's equal to 0. And then moment equation. So we have a choice here. We could do moments about any point you like. I would say you want to choose a point where maximum forces act upon, so that you can. So it's super easy to write the equation. So if you write moment equilibrium about G, then the contribution due to N, mg is going to be 0 because those two forces pass through G at the center. If you take moment about point A, then N, Ff, mg, all three forces pass through A. So those would have 0 contribution. So if you take about G, you'll have two forces appearing in the equation, P and Fs. If you take the moment about A, only one force will appear, P. So I would just choose A. So moment about A is Rg with respect to A crossed with mass times, it's going to be acceleration in the x direction, we know that, plus Ig times alpha. So this gives me moment about A due to P is going to be P times the larger of the two radiuses. So sorry, this is going to be 200, this is 400, so it's going to be 600. So P times 0.6 because I want it in meters. So the moment about A is going to be clockwise or counterclockwise. What's the sign on this? it's going to be, oh my bad, 250 plus, good point, 250, so it's going to be 650. Yeah, okay, thanks. What's the sign on this? Positive or negative? Negative, because it's going to, the moment about A is going to make the thing turn clockwise. Okay, so let's try to find this next. So MA is this way, the vector from A to G is this way. So when you take the moment about A due to MA, it's going to also create a clockwise moment. So it's going to be negative mass times acceleration x times the distance A to G, which is 0.4. And then I'm going to assume that alpha is clockwise. So it's IG times alpha. Okay. The negative sign here is because MA produces a clockwise moment about A, like I showed you there. This will produce a clockwise and then this is because alpha is clockwise, so IG alpha is going to be negative. Okay, so let's count the unknowns since we used up all the equations. So P is P is known, FF is an unknown, acceleration x is an unknown, n is an unknown, what else? Alpha is an unknown. So we have four unknowns: AX, alpha, n, FF, but three equations. Okay, so we cannot solve for four unknowns with three equations, so we need to generate the fourth equation. The fourth equation for this particular problem comes from assuming cylinder is rolling. The fourth equation is AG equals, or AX equals R times alpha. So now we have four equations: 1, 2, 3, 4. Four equations and four unknowns. Okay, so when you assume it's rolling, do not assume the friction force is mu times n. That's not right. Assume FAG equals R alpha. So we can solve for the four unknowns. If you solve for them, you get, yeah. No, so you're asking if FF is mu k times n. Is that the question? Yeah. If you find n, which you can from this equation, can you find? That's not right. Not true for rolling. Don't use. Okay, don't use this. This is only true for sliding. So if I told you this object was sliding, or we found later on when we solve this for friction, I'll show you how to find if it's sliding or rolling later on, but it's only true for sliding. Do not use it when it is rolling. Very common mistake. Yeah.
Oh,
question.
When you did the moment A,
yeah.
Do we know if you parallelize the theorem?
Okay, so you can use the parallel axis theorem provided it is rolling. So what you're trying to say is, if you look at this carefully, it automatically comes out to be IG plus M R square times alpha, right? If you put AX equals R alpha, you get this. So it looks like parallel axis theorem. This is the parallel axis theorem. This will only work if it's what. How do you get this from here? Well, you assume AX equals R alpha, and that's how you got this. Now, what will happen is if it is sliding, this is not true. This will, you cannot put A equals R alpha, and this will not hold true. So for rolling, yes, you can do this. For sliding, no, don't use this. Don't do the simplification. Only true for rolling. So if you got confused with this, I tell you don't bother, think about it. There is a simplification you can do, but it's not worth it because if you get confused, very likely you get it wrong. Just keep it as it is and solve for it later. Okay, but there's some trick. You can play a trick here by simplifying it, but don't worry about it if that confused you. So do not use that for rolling. Please don't use that. It's an easy way for us to deduct points. Don't write that. Write that and you get points. In fact, when I grade this question, if I'm going to grade, I actually give you points for setting up all these equations right. You get, if you come up to here, you probably get like 60-70% of the points if you set up all these equations right. The signs included, okay? Signs and put in the values, you should get about 60-70 points. So just getting there will give you points. Okay, now let's try to solve for I'm just going to write the answers from the book. Alpha is 1.3 radians per second square. AX is 0.52 meters per second square. The reaction force comes out to be 981 newtons, which is very easy to see from here. And then the friction force actually comes out to be -2 newtons, which means that the assumed direction of friction is not right. It's actually acting to the right side, not to the left. So once you get to this point, you've computed, you solve for the four equations, 4 unknowns. You need to do this check. Check for rolling. So how do you check for rolling? The condition for rolling is that the friction force max, okay? By that I mean mu s times n should be greater than the friction force which you found. So mu s is 0.2, normal force is 981, which comes out to be 196.2 newtons, is clearly greater than 2 newtons. What this means is that that there's enough friction to prevent this thing from sliding. So that's true. So we can say is true. Spool is rolling. So the way we ask you this question is, one way to ask is, we'll set up a problem, we'll say it's rolling, and then ask you, can you check for rolling? So if you do this check, you will solve for these 4 things. In fact, not 4, just friction force. You show this is true and say that it's rolling because of this, then you get the rest of the points. Now, if this was not true, what if this was less than FF? If it was less than FF, then this particular spool is not rolling, it's sliding. And then what you need to do is you need to take the same three equations. So you don't have to do anything with those equations. Keep those equations as it is, the first 3. F equals ma, those 2 equations and n. But replace this equation with this equation. So when you write those 3 equations, you see there are 4 unknowns. Your fourth equation which helps you to solve it will come from here. So take this equation, that will be your 4th equation, solve those 4 equations, and you will see that actually AX will be not equal to R alpha. So all these things actually put it over here. Okay, you got to check slipping and so on. So if it's slipping, what do you do? If it's rolling, what do you do? So go through that. Okay, so I have time for one more. Are there any questions on this? Yeah. Uh-huh. Yeah, so we check this. If this comes out to be less than, it says sliding. We may ask you find the acceleration in that case. So in that case, then if we ask you for the acceleration, then you're going to go back to the four equations. Well, the fourth equation is this one. Solve it again. But most of the time we don't have time for that. So we usually ask you to check for rolling and we stop there. Any other questions, by the way, on that? So please solve number of questions on rolling. It's important. Okay, using a fork rod or 0.5 kg smooth peg. This is a 0.5 kg peg. Is forced to move along a vertical slotted path R equals 0.5 theta, where theta is in radians. If the angular position of the arm is theta equals pi divided by 8 t square, where t is in seconds, determine the force of the rod on the peg and normal force of the slot on the peg at the instant t equals 2 seconds. The peg is in contact with only one edge of the rod and slot in time. The last statement simply is saying that this peg is in contact with only one surface, which is this surface and this surface of the fork rod. It's not in contact with two. The reason why they want to say it is because if it's in contact with both, then there will be two forces, and then it's not, you cannot find the force uniquely. So it's in contact with only one thing. So that is one of the surface of this and one of the surface of that. There will be two forces. You asked to find those two forces: force of the rod on the peg and normal force. So let's draw the free body diagram of the peg. So we'll have a force from the peg acting at right angles to this surface, right? So it's going to be F, P is going to be the way it is shown. The force between the peg and the slotted path is always going to be normal to the slotted path at that point. So at any instant of time, you can actually find a normal, right? And then normal keeps changing. So you can assume it in either direction. So let's say this is the force. I think gravity acts too. It's not given here, but I mean, we'll give you if there's gravity or no gravity, but there's gravity in this problem. Okay, next we move to the equations of motion. So you're not given the dimensions of the particle, well, the object. So this is a particle problem. So you have to write the equations of motion. We need to step back and ask ourselves, what's the coordinate frame to use for this problem? Right? The hint is when you're given r as a function of theta, so the best coordinate frame to use is r theta. This is r as it is shown here. This is theta. So in order to solve for the forces, we need to write the equations, right? So the question is, do we know, we know how Fp acts. It's acting along theta, right? Because that's right. So is that true? So it's not clear if it's not acting on theta. So I'm at this point where I need to eventually resolve the normal and Fp forces along theta and r direction, right? And from this figure, I'm not able to do that. I do not know what the angle n makes with r theta. It's not there in the figure anywhere. Okay, so this is actually one of the problems where the forces are in the nt frame, but the kinematics are in r theta frame. So this is where you're going to find the angle psi. You remember there was a psi angle, which is a formula in the book. Says psi is r d theta. I think I did a mistake in my notes. Psi is the angle between r and t. I think I said n and r in my notes. So we can find psi. It's simply 0.5 theta. Well, r is 0.5 theta, so d theta is 0.5 theta. So I'm going to put that over here. So it's 0.5. So psi is theta, which is equal to do I know anything about theta? Well, I know theta is pi by 2, pi by 8 t square. I need to know psi at t equals 2 seconds. So t equals 2 seconds at pi by 8 times 2 square. It comes out to be pi by 2. That's interesting. It's 90 degrees. Oh, sorry. It's tan psi. My bad. The formula is tan of psi. Yeah, question.
For this particular problem, will we be able to use the alpha omega equation by deriving r and theta, and by using our alpha multiplied by r and that gives us our acceleration?
What's alpha omega equation?
The r dot, alpha dot, or omega dot, use that like alpha times r acceleration.
So you're trying to use the AT and A theta. No, that will not work. It will not work because it might actually work, but it will be a long route. The reason why it will not work is because remember that formula, there will be a rho, mv square divided by rho. That rho is d square dy dx, something like this. You do not know y as a function of x. That will throw you off. Okay, so from this psi comes out to be 57.2 degrees. I'm out of time. I'm going to set up the equation and let you go. Okay. So once you get psi, you actually found the angle which r makes with the tangent. This is the tangent line. So psi is the angle between r and t. R is this, t is this, so this is psi, so this is psi. So now we're in a position to set up the equations. I'll set up the equations and let you go. Okay, equations of motion. So I'm going to resolve n. In the r direction, so n sine psi so that's in the r direction, minus mg equals mass times acceleration in the r direction, which is r double dot minus r theta dot square, right? And the second equation is in the theta direction, so this is in the fr is mass times ar. That's the equation. The second equation is n cosine psi, that's in the theta direction, minus fp equals mass times action in theta, which is r dot theta dot plus r theta double dot. So this is f theta is ma theta. Okay, so given these two equations, now I can, we have two equations. You can actually solve for r and theta, r double dot and so on, because given theta as a function of time, I'll use that to find n and fp, and that's what I'm asking for. Yeah, see you on Friday. Please come prepared for the class like you'll be prepared for the exam, because we'll have eye clickers. Don't forget eye clickers. I'll see you on Friday.